Hi, I'm Tim Dr. T. Shamillard, and I'll be your instructor for this course. I'm an associate professor at the University of Colorado at Colorado Springs, where I teach a variety of game design and development courses. I'm also the founder of and program director for our Bachelor of Innovation in Game Design and Development degree at UCCS. I have 5.5 years of indie game development experience in a company that I formed with my two sons, and now I do my game development in my one-man shop, Burning Teddy. Just like the previous course, this course is structured as 4 weeks. Each week has an automatically graded quiz that you have to score an 80% or better on to earn the certificate for the course. There are also a number of exercises in the course that aren't worth any points, but are good for you to do as much as you can to learn the course material. In the last week of the course, there's also a quest that you can use to practice your GameMaker development experience even more, to expand your horizons in your game development skills. The first week has the Getting Started lesson, which you're doing now, and finally we'll add player movement to our games so we can finally have player interaction with our games. In the second week, we'll add shooting to our games. In the third week, you'll learn how to debug your games in GameMaker, and that's a useful skill to have. And then in the fourth week, we'll add health to our games, and of course you'll have your finishing up video. This course builds on the foundation we started to develop in the first course in the specialization, and it's based on the continuation of that first game design and development course at UCCS. As always, if you run into trouble, you should post questions on the discussion forums or go to the web for help. In this lecture, you'll learn how to navigate one of my courses on Coursera. And although this is almost definitely not the course you're currently enrolled in, that doesn't really matter. All my courses on Coursera pretty much look the same. Let's go wander around the course. This is the first course in the specialization, and you can ignore this assessments overdue message. That's just because I'm currently editing the course. Over here on the left, you can pick the week for which you want to look at the material, and we'll take a look at week 1. So the first thing you should do for a particular week is you should read what it's all about for this week. I say module, but it's really just that week's content. You can show the learning objectives for the week so you can see what you should be able to do by the time you finish the week's work. And then you can see there's lots of videos and other materials. So if we look at the sprites lesson, we can see there are some videos that you should watch. And there are also exercises, stuff that you should do to practice with the course material. These are not automatically graded. In fact, they're not graded at all. So you can just mark them as completed when you finish them if you want. But for a particular video, like sprites and sprite strips, you can see there's the actual video, and if you scroll down, there's also a downloads section where you can download the lecture video, or the subtitles, or a transcript. The PDF file here will be a copy of the PowerPoint slides that I used for that particular video, and if I've generated code in that video, here's a zip file with the code that I generated as I did that video. So you can always download the code that goes with a particular video by going to Downloads under the video and then picking that zip file. If you download it, you do need to extract the files from that zip file before you try to run the GameMaker games or anything like that. So you can't just run them from within the zip file. You need to extract the files from the zip file first. The other thing you can see on week 1 is there is a quiz. It says it's overdue, but it's not. But every week you'll have a quiz that you need to complete. And those quizzes are graded. I will also say that each week contains a discussion prompt. And if I click this discussion prompt, you'll see that I can type a reply to a particular prompt, something that gets you thinking about game development and the aspect of game development that we covered in this particular week, so that you can just sort of reflect on what you've learned and how it might apply to game development. If I go to week 4, every course in the specialization has an optional quest. So some game that you can develop to hone your game development skills in GameMaker even more. It's optional, it's not graded. The only thing that's graded is the quizzes, but this also lets you develop more games in addition to the small exercises you've done throughout the course. You can also, on the left, look at your current grades in the course, and I haven't submitted anything yet, so I don't have grades for any of the quizzes. You can take notes. There are also discussion forums. So I have a discussion forum for each week, and if you want to post a question or comment about the topics for that week, you just go to the discussion forum and start a thread and so on. So that's a whirlwind tour of how you actually navigate one of my Coursera courses. But even if the course you're currently in is not the first course in the specialization, they are all formatted the same way. And there you go. That's how you navigate one of my courses on Coursera. This is the totally optional, don't watch it if you don't want to, meet the instructor lecture. I'm Tim, Dr. T. Shamillard, and I grew up in a small town in southeastern Massachusetts named Norton. And after high school, I went off to Georgia Tech to pursue a bachelor's in electrical engineering degree, but I was only at Georgia Tech for a year. So if you'd like, pause the video and guess for why I only stayed for a year, and then continue. As one of my past students said, I left for the love of a good woman. So my girlfriend was in Massachusetts, Georgia Tech is in Atlanta, Georgia, and that was too far for me. So I spent about a year and a half putting stuff into boxes and handing it to the UPS guy. And then I enlisted in the U.S. Air Force, went off to basic training, went to technical training school, and after about 4 months in the Air Force, I got married. So pause the lecture again if you'd like to decide whether that was the same girl I left Georgia Tech for or somebody else. The answer is it is in fact the same woman, and we are still married. So here we are in the Air Force. We went off to Omaha, Nebraska for our first tour, and then after 16 months, the Air Force decided to send me to school full-time to pursue a bachelor's degree in electrical engineering at Georgia Tech. So I did get to finish that degree at Georgia Tech in electrical engineering, and then I went off to officer training school and got my commission as an Air Force officer. Our first assignment in the Air Force was at Los Angeles Air Force Base, where I spent 4 years managing contractors writing software to help us fly satellites. Particularly orbital software was my general area of expertise. We had our first 2 children, both boys, while we were in Los Angeles. And I also pursued my master's degree in computer engineering at the University of Southern California, going to school nights. Finished that tour after 4 years and went off to the U.S. Air Force Academy, where I taught undergraduate computer science courses for 2 years. Now, the Air Force Academy is usually a 4-year tour, but I only spent 2 years there. So if you'd like to pause the lecture video again and try to guess why I only spent 2 years, go ahead and do so. The answer is the Air Force decided to send me off to UMass Amherst to pursue a doctorate. So I am in fact a doctor of computer science, so I don't actually help people. And my entire family loved the part in Treasure Planet, the movie, where there's a non-medical doctor and he is trying to help somebody who's injured, and he says, I just sit here and I'm useless. And I saw that movie with my entire family at the movie theater, and at that line, every single person leaned over and looked at me. So everyone knows I'm a doctor, just not a real doctor. Okay, so I finished off that degree and went back to the Air Force Academy for that full 4-year tour that I should have had in the first place. And then my final assignment was to Washington, D.C., where I spent a couple of years managing contractors, developing web applications, and the databases that support those web applications. And then I retired from the Air Force. So I've been at the University of Colorado at Colorado Springs since 2003, and I've taught a variety of courses, including graduate-level software engineering courses, undergraduate computer science courses, and undergraduate game design and development courses, all of which I created from scratch. And in fact, we now have a Bachelor of Innovation in Game Design and Development, and I teach many of the beginning and the final course in that particular program, and I'm the program director for that program. So at this point, I exclusively teach game development courses. I also spent a year and a half as an indie game developer in a company that I formed with my 2 sons, and that's Peak Game Studios. And we did a number of games both on speculation and on contract. So here are the games we built on speculation. The 2 images on the left are a game called Ket that's based on an actual board game. So we got the license from the board game manufacturer. And you can think of this as chess with lasers. And you can actually download a free version of this game at this point from the Burning Teddy website. I'll talk about Burning Teddy soon. The other screenshot from the upper right is for a game that we didn't quite finish as we shut down the company once my sons sort of grew up and moved on to do other things. And that game is called Battle Paddles. And you should think of this as Pong with weapons, because that's sort of the big idea behind that game. We didn't quite finish it, but we'll get back to that game as well. So on this slide are the games that we built under contract. So as a company, we went and we got a contract to build some games, and we actually got paid to build them, and that was awesome. So the 2 on the left are for educational games for 8th graders. The one all the way to the left was a set of 4 mini games to teach about physics. And the title of that group of mini games was Physics with Neat Details. And if you think of the acronym for that, it's PWND. And so, of course, a little tongue-in-cheek game development, of course. And the lower one was to teach 8th graders about robotics. So they would configure a robot with various attachments to go complete a number of missions. Again, there were a few mini games to do. The upper right one is something called Colorado History Arcade. We got a contract to teach 4th graders about Colorado history, and that game was deployed on the Pikes Peak Library District website. So all of the games we built as a company, except for the Colorado History Arcade game, were using C#. We happened to use XNA Game Studio to do that. But now, of course, we've moved on to Unity. The company hasn't, but I have. And so that brings us to this next slide, where I tell you I now have a small company, and by small I mean just me, called Burning Teddy. And I use that company to publish textbooks and online courses, and of course, also to do game development. So that Battle Paddles game that I showed you the screenshot from, I am in the process of porting that over from XNA Game Studio to Unity. That is about 60,000 lines of code, so it's going to take a little while to port, but at some point that will be on the Burning Teddy website, burningteddy.com. And I'm also working on another smaller casual game that is called Balloons Extreme, and I'll actually post my progress on burningteddy.com as I build that game in Unity. So Burning Teddy, all the game development I'm doing is actually in Unity. So when I'm not teaching and I'm not doing game development, what am I doing? Well, a number of different things. But one of those things is cycling. So riding a bike is one of my joys in life, I guess. So these are my 3 bikes. The blue one is the oldest one, and that's really an old bike at this point. But I used it to really get into cycling, not racing so much, but doing long rides like a number of centuries, which are 100-mile bike rides, including, at the time, one of the 10 toughest centuries in the United States. And so that century had over 10,000 feet of climbing. That's what makes 100-mile bike ride harder than another is, elevation gain. And so I did a number of bike rides. The mountain bike, the one on the bottom, is a result of going mountain biking with some friends one day, and I loved it so much that I went out and bought the mountain bike the next day. The bike all the way on the right is my triathlon bike. So, being a cyclist, I did a lot of long rides. I also did a bunch of running, including a number of marathons and a running race that goes from the bottom to the top of Pikes Peak here in Colorado Springs. I did that running race multiple times. And once you've biked a long time and run a long time, you say, well, you might as well do some triathlons as well. Just add a swim and you'll be fine. And so I've done a variety of triathlons, all the way from sprint distance, which are really short, all the way up to an Ironman distance race. I also play guitar. I started doing that way back in high school and then gave it up for decades while I was raising my family and doing other things. And now I've started up again to try to learn how to do it even better than I used to. So moving from left to right, the acoustic is a Yamaha acoustic that I bought way back while I was just out of high school. The next guitar is a Joe Strummer replica. Fender came out with a Joe Strummer tribute guitar some years ago, and that was my starting point. But I replaced the 3-saddle bridge with a 6-saddle bridge because that's what Joe Strummer used. I got that relict pick guard from a place called Extreme Creations, and I even took the stickers that were on Joe Strummer's guitar and cut them into the shapes that they were worn into by the time Joe stopped playing the guitar, and affixed them to the guitar in the appropriate places. The next guitar is a Gibson Les Paul Gold Top from a couple of years ago. And the one all the way on the right is my most recent guitar. That is a Fender Stratocaster American Professional 2. And I didn't have a Strat, so I wanted a Strat. But I also couldn't resist getting it in the gorgeous Miami blue color. Really, the other thing, other than, interesting, like, reading books and stuff like that, the other leisure thing I do is I play video games. That should come as no surprise to you. And so the question is, what kind of video games do I play? And you should pause the video, guess in your mind what those might be, and then you can move on to see a screenshot of what I use to play my video games. You can see racing games are my passion, so really racing simulations, so, realistic racing games rather than arcadey racing games. And if you're interested in all the details of that racing rig, you can go to the PDF that I've provided as a resource for this lecture. So there you have it. None of this has anything to do with course content, but it gives you a little more insight into who's teaching you in the course. What will you learn in this lesson? You'll learn how to implement avatars in your games. You'll learn about clamping, specifically how to clamp the player's avatar so it stays on the screen. And you'll learn about collision masks and bounding boxes. Okay, the title of this lecture is also the title of a song by one of my favorite groups of all time. So if you've never checked out a group called The Clash, you should go do that now and then come back to this lecture video. Once you do, within this lecture, we're going to learn how to clamp the game object so that it stays within the screen. And the word clamp is used when we talk about keeping a particular value within a range of values or a specified set of values. So we clamp a value to stay valid. The other issue, though, is I can leave the room. And while that doesn't matter at this point because I don't take any damage as a burger, our game will get to the point where the teddy bears fight back and we don't want the player to be able to sort of sneak out of the room to hide. So we want to clamp the player's avatar so it always stays in the room. Again, we'll just look at left and then I'll add the rest and we'll come back and see it again. When the player presses the left key, we need to decide if there's room for the player to move to the left. And we're actually going to use something called an if statement to make that decision. So we're going to grab this action. We'll check if an expression is true or false. And I will only move by move amount if the expression is true. So I need to grab this action and I put it over here. And you should be able to see, right, that it moved over to the right and it has a green line now. So that means that this will only happen if this expression is true. So how do we know if we have enough room to move to the left and still stay in the room? What we need to know is, and drawing a picture might really help with this. So what I need to know is if x minus half the sprite width minus the move amount is greater than 0. If that's true, then I have room to move to the left without going outside the window at all. I'm going to come back to my create event because I'm going to check this every time the player provides input to the left. I want another variable that I've declared called half sprite width. And one of the built-in variables we have is sprite width with an underscore like this. And I'm going to divide that by 2 and assign that value to this variable I've declared called half sprite width. And I'm doing that so I don't have to do that division on every frame that I have input, because division costs CPU time. I'm going to have a half sprite height as well because I know I'll need that. And that is just another built-in variable, sprite height, divided by 2. Okay, now back to my expression, which is in my key down left. If x minus half sprite, I tried to tab, half sprite width minus move amount is greater than 0. If that is true, I have room to move to the left. So let's see how this works. I can move to the left, but then I get stuck right there at the edge. Now you might say, that looks great. But if I actually change my move amount to be something much larger, let's say 30, and I run the game again, I moved to the left and you can see there's a big gap between the edge of the burger and the edge of the room. So I need to be a little more precise if there's not enough room. So back here, I want to add an else to this if statement. So basically, this part will happen if my expression is true, but if my expression is not true, I want to assign x to be some value that will have the burger slammed up against the left side of the room. So if you think about this, the x is at the center of the burger. So if we set x to be half sprite width, then it's going to be slammed up right against the edge of the room. So I'll run it again at the super fast speed, and you can see I get right up to the edge of the room. So this is a really good pattern for us to use to keep our burger clamped on the left-hand side. I'll go do the other 3 directions and then we'll come back. Okay, I've done all of them, so let's look at moving to the right. Here I have to check if X plus half the sprite width plus the move amount is less than the width of the room. And it turns out that we have a built-in variable called room width that tells us the width of the current room. So this handles all the clamping. I'll run it to show you. And I did up, down, left, right, and of course I still clamp even if I move diagonally. So you should look at the logic and the Y actions on your own for up and down, but it's the same idea as what we just did in X. Let's go do the same thing in our GameMaker language project. In my create event, I need to add a couple more variables. Half sprite height. I did width first before, so half sprite width equal sprite width over 2 half sprite height equal sprite height over 2. And let's just go implement the key down left. We had an expression. So instead of dragging an if block over, I say if, and then I put my expression in between these parentheses. And then I will actually do some stuff between curly braces, and then I have the else part, and I'll do some stuff between those curly braces as well. Now our expression for left was if X minus half sprite width minus move amount is greater than 0, then I set X equal to X minus move amount. And there are a variety of different ways that we can set X equal to X minus move amount. I'll just leave it like that for now, but there are other ways to do that as well. Otherwise, I set X equal to half sprite width. So this was, I didn't have enough room to move, so I slam it up against the left edge. And when we run our game, you'll see that I've moved and clamped my burger just like we did in the drag and drop game. I'm not going to go through the rest of them here in this GameMaker language project, but I will add that code so when you download the materials for this video, you can actually see moving to the right, moving up, and moving down as well. Before we finish the lecture, you should do an in-video quiz showing your understanding of clamping. To recap, today we learned how we can clamp a game object's position to keep it inside the screen. In the previous lecture, you learned how we can clamp the player's avatar in the screen. Unfortunately, the approach you learned doesn't work if there's extra transparency around the image. Why not? Because sprite width and sprite height are the dimensions of the actual sprite, not the image within the sprite. What can we do about that? When we import a sprite into GameMaker, GameMaker generates a collision mask to be used for collisions for any instances that use that sprite. We can also use information that's generated from that collision mask to get precise clamping. Let's see how. This is our code from the previous lecture. So when we run our game, you can see on the left and the right, I clamp pretty well, but there is a little gap that you can see at the top and the bottom, which I didn't show you last time. And let's change the sprite for the teddy bear to have even more transparency around the edges so we can more easily observe this problem. I'll import a new sprite, and this is a larger burger that is 64 by 64. So you can see there's more space around the edges, both at the top and bottom and the left and right. If we run our game again, you can really see that gap on the top and bottom, and even on the left and right, you can see there's a bigger gap on the left and right. So how can we fix this to be pixel perfect as we clamp inside the screen rather than just using the actual dimensions of the sprite itself? Because sprite width and sprite height are 64 and 64 in this particular case. Let's go to the GameMaker manual to see if we can get some ideas. In the GameMaker manual, I've gone to the Instant Variables section, and we looked at this section before when we were talking about built-in variables in GameMaker. When I talked about those built-in variables, I talked about these general variables here, and I talked about movement and position, but I didn't scroll down. And if I scroll down, we can see we used sprite width and sprite height before, but if we keep going, we see we can find B box bottom, B box left, B box right, and B box top. So these are for the bounding box. I'll click that one. So it returns the Y position within the room of the bottom of the bounding box. So the bounding box is defined by the maximum width and height of the mask, the collision mask. So this isn't the sprite dimensions, this is the collision mask for the sprite. So we should be able to use these variables about the bounding box to get more precise clamping for our burger. Back on the burger sprite, by the way, I can expand collision mask, and you can see it's set to automatic rectangle, and you can see this darker part is actually the collision mask. So let's go to our burger object, and instead of setting half sprite width and half sprite height, let's set half bounding box width and setting half bounding box width will be, if you think about this, B box right will be the rightmost edge of our collision mask, and if we subtract B box left from that and then divide by 2, that will be half the width of the bounding box. If we do the same for the height, we'll need to do the bottom of the bounding box minus the top of the bounding box, and of course divide by 2 again. And unfortunately that means that all of these things break. So I'm going to change every instance where we have half sprite width or half sprite height to half bounding box width and half bounding box height, and then we'll come back and see how everything works. And now that I've done that, when we run our game, we can see on the left, on the bottom, on the top, and on the right, we get pixel perfect clamping, and the burger is precisely inside the screen on all 4 dimensions. Over in our code game, you see in the create event, I set half bounding box width just like we calculated in our visual game, and the same for height. And I changed the left key down, the up key down, the right key down, and the down key down to use half the bounding box height and half the bounding box width. And if I run it here in my code game, you can see I get that precise clamping here as well. To recap, in this lecture you learned that GameMaker generates a collision mask for every sprite that we import into the game. And you also learned how we can use bounding box information, which is generated from that collision mask, to get precise clamping. Although driving our burger around is fine, this isn't a shooter yet. In this lecture, we'll add projectiles to our game. I've already added a sprite and an object for our projectiles that the burgers will shoot, and those projectiles are, in fact, French fries. So we'll start as usual in our drag and drop project. The first thing we want to do is to be able to shoot the French fries. And the appropriate place to do that is within our burger. I'm going to add an event, and it will be key down, and it'll be the spacebar. So I will be able to shoot a burger by pressing the spacebar. And over here in the action toolbox, we can see we have a create instance action we can do. So I'll just grab that, and I will pick the French fries object as the object I want to create. And I've centered the sprite, and I want the French fries to be centered on the burger, so I can set the X and Y location for the French fries, but I do need to click the relative checkbox because that will make sure that I'm actually creating that new instance at 0, 0 relative to the burger, rather than at 0, 0 the upper left-hand corner of the screen. We'll leave the layer instances the way it is right now, though we will see by the end of the lecture that we need to change that, but that's what we'll do for now, and we don't need to worry about the target and the temp. The target would let us actually save this instance into a variable so we could do other manipulation with it, but we don't need to do that. We just need to create the instance here. When I run my game now, when I press space, you can see I'm creating French fries, and that doesn't hurt the teddy bears at all. Those don't inflict damage, but by dumb luck, the French fries are appearing below the burger, and that might not be the case. If we come back to the room and I select the instances layer where I want to add an instance, if I drag my French fries over onto that layer, you can actually see that those French fries appear on top of the burger. So we don't want to trust to luck that everything will work out okay. First, we're going to delete those French fries. And now I'm going to add another layer. And I have to be careful. I don't want to add a background layer or a tile layer or anything like that. I want to add another instance layer. And I'm going to rename this layer Projectiles. And I will add my fries to the projectiles layer. Now you can see that still puts it on top of the burger because the layers are ordered. This one gets drawn on top, and then this one, and this one, and so on. So if I want my projectiles to be below the burger, I just grab that layer and push it down below, and you can see that now it's below the burger. If I pick the instances layer, that's where all my teddy bears and burger are. If I pick the projectiles layer, that's where my fries are, which we can't see because it's hidden by the instances layer, which I can turn off with this little eye symbol here. And so now I can see the things that are in the projectiles layer. But using different layers in the room make it so that we can control the order in which stuff is drawn. And that's a really useful thing for us. What that means, though, is we should now come back to our burger, and we should say we want to create our fries in the projectiles layer, not in the instances layer. And we'll run it again to make sure we didn't break anything. And as you can see, I can still place these landmine projectiles. Okay, next thing. Let's actually make it so that the French fries destroy a teddy bear when they collide with the teddy bear. We already have this mouse enter for the teddy bear, where we change its instance to an explosion. So we can actually just change this event. So I'm going to change the event, and I'm going to select collision with an object the French fries. So now, when a teddy bear collides with French fries, it will turn into an explosion. We could do this collision detection and collision resolution in two different places. We could do it inside the French fries, because that's one participant in this collision, or we can do it inside the teddy bear. And I chose to do it inside the teddy bear because we could later modify our game to reduce the health of the teddy bear, but not kill it on the very first collision with French fries and so on. And the teddy bear object would be a more logical place to include that processing. But for our game right now, either one works fine. Detecting and resolving the collision in the French fries, or detecting and resolving the collision in the teddy bear. Okay, let's see how this works now. We see that the teddy bear does in fact explode when it hits the French fries. This isn't really a shooter at this point. This is a placing French fry landmines game at this point. So to actually shoot the French fries, I want to add a create event to the French fries object, and I'm going to get the French fries moving. So I need to go down to movement, and my French fries are just going to shoot straight up. And I will set the speed for my French fries to be something faster than teddy bears. And that speed will be 10, let's say. So now when I run my game and I hold down the space bar, I send up a stream of French fries and I destroy the teddy bears. Now, all those French fries that go out the top of the room are actually still kept in the game. They're still included in updating the location of the French fries every frame of the game and so on. So for efficiency, we don't want to keep those French fries in the game after they've left the room. We actually want to destroy them if they go outside the room. So I'm going to add an other event outside the room. We've seen this before for screen wrapping, but this time when a French fry goes outside of the room, we'll actually destroy the French fry. And you can't actually see that happening as we run the game, but it is happening as we run the game, and that's really important. By the way, you may have noticed when I run the game, I immediately shoot a French fry and I'm not touching the spacebar there. That's because in my room, I had actually placed a French fry in the projectiles layer just to show that layering. So I need to delete that instance and run the game again. And I don't shoot a French fry when the game starts. I only shoot French fries when I'm holding down the spacebar. I know the firing rate should be controlled, and that's for next lecture, not this one. Okay, I decided to actually show you how to destroy the French fries when they collide with the teddy bear from within the teddy bear object. So here's where we're turning into an explosion. We also drag over a destroy instance, but we don't want to leave it just like this because that would destroy this instance. And we want to destroy the other participant in the collision. So if I click this down arrow, I can select other instead, and that will destroy the other participant in the collision, which in this case, because we're doing this from the perspective of the teddy bear, the other instance is the French fries that we just collided with. Let's run it and check that works. And you could see that there was a gap in my stream of French fries showing that the French fry that collided with that teddy bear was also destroyed as part of the collision resolution for that particular collision. To recap, in this lecture we learned how to add projectiles to our game, and we also learned about the importance of destroying our projectiles when they leave the room. Last time, we learned how to add projectiles to our game using visual events and actions. In this lecture, we'll learn how to do the same thing using code. The first thing we'll do is create a French fry object on every frame in which the space key or space bar is down. And now we need to know how to actually create that object. Let's go to the GameMaker manual to see how to do this. And we'll search on instances because we're trying to create a new instance of an object. Let's pick instances. And look, the very first hit is instance create layer. With this function, we can create a new instance, and that's just what we want to do. So we'll scroll down here and look at how we call the function. And when we call the function, we provide 4 arguments. We provide the X position for where the object will be created, and the Y position. We provide the layer ID, or the name of the layer, so this is our projectiles layer. And we provide the name of the object, in this case our object fries that we're going to create. There is an optional argument here that we're not going to use when we call the function, so we'll just call the instance create layer function with the first 4 arguments here in the documentation. Now, X is interesting, right? Because in the drag and drop code, we said X should be 0, but it should be relative to the burger. Luckily, we're in the burger right now, so we can just say create the French fries at my X and Y, because that will be at 0, 0 relative to the burger. The next thing was the name of the layer, so that's projectiles layer. And then finally, the name of the object that we want to create, and that's object fries. So let's run our game and test that. And it works the same way as before. The next thing we did was make the teddy bear. Instead of using the mouse enter event to change into an explosion, we changed this to be a collision with the French fries instead. So now for a collision with the French fries, we'll turn into an explosion. So we'll run to test that piece. And I will say, in both the drag and drop project and in this project, this didn't work the first time I tried it. I actually had to restart GameMaker Studio. That's got to be a bug in GameMaker Studio, but I'm going to restart and we'll check that out again once I have. Now that I've restarted it, it turns out that this code is blank. So I need to redo the instance change. And I need to say what to change into. And remember, I need to say true to make sure the create events work for the explosion. Let's go ahead and run and see what happens. Great, it blows it up. Now, not only should I change the teddy bear into an explosion, but I should also destroy the French fries. And it turns out that I can say instance destroy, and I can say other, and that means destroy the other participant in the collision, which in this case, because I'm doing this from the teddy bear perspective, is the French fries. I'll run, and once I can get a teddy bear to run into it, you can see there's now a gap in my French fries, so it hit that one right there. But it's important to destroy both. Otherwise, the French fries could tunnel through one teddy bear, turning it into an explosion, and keep going and get another teddy bear, which is an interesting gameplay mechanic, but not what we want. Okay, we also, for the French fries, we got them moving. And we did that with our direction going straight up, which is 90 degrees. And we set our speed equal to 10 so that it's faster than teddy bears. So we'll run that. And finally, we said when the French fries leave the room, we should destroy them because we don't want them to keep getting updated in the game after they've left the room. So you can't actually see this, but it is in fact happening that the French fries are getting destroyed as they leave the room. I'm chasing them. There we go. And you can see again that those French fries that collide with the teddy bears are getting destroyed when they collide with the teddy bears. To recap, in this lecture you learned how to add projectiles to your game using code. Although firing projectiles every frame is fun, it makes the game way too easy. In this lecture, we'll learn how to control our burger firing rate. A sentence I never thought I'd say. Let's go see how we can do that. The big idea here is that when we fire a projectile from our burger, we'll start a cooldown period, and we won't be able to shoot again until that cooldown period has expired. We'll start by going to our create event, and I'm going to declare another variable that I want to use, and I'll call it can shoot. And this variable will just be true or false. If this variable is true, I can create a French fry. If this variable is false, I can't create a French fry. We'll start it at true so that we can, when we start the game, the player can shoot a French fry. We'll also set another variable that I will call cooldown frames. So how many frames are we going to cool down for before we can shoot again? And I will set this to 30. Next, we'll go to our spacebar event. And here we're automatically creating French fries. But we don't want to do that. What we want to do is we want to check if in fact the can shoot variable is true before we create French fries. So let's do that test. I'm going to pick a different form of our if statement. So I'll pull this over and I'll immediately make sure the create instance goes inside the if. And this time I'll say if can shoot is equal to, you can see I can pick equal, less, greater, less, or equal, or greater or equal, if it's equal to true. I will let the player shoot, so I'll create the French fries, but I will also set the can shoot variable to false. So that means when they shoot, they can't shoot anymore. Let's see how that works. So I can fire one French fry and that's it. I can never shoot again. That's of course not how we want the game to work. We want to start the cooldown period at this point. The way we're going to start the cooldown period is we're going to use something called an alarm in GameMaker Studio. The idea of using timers, that's the more common terminology, the idea of using timers to cool things down or to do other things in the game, decide when you should spawn new things and so on, is very, very common in game development. And our mechanism for setting up timers in GameMaker Studio is an alarm. So here, you can see I can set an alarm countdown, and I won't set it to 30, I'll set it to cooldown frames. You'll notice that I have a lot of alarms I can set. I have 12, numbered from 0 through 11. Programmers very regularly start counting at 0, and the more programming you learn, somewhere along the way, someone will explain to you why we start at 0. There are actually really good efficiency reasons to start at 0 instead of 1. So we'll just set alarm 0 to cooldown frames. That means that at this point, if the variable is true, I'll create French fries, I'll set can shoot to false, so I'll make it so I can't shoot anymore, and I'll start this alarm 0. If I run the game, I still can only shoot once, and I can't shoot anymore. And the reason is because we never respond to the alarm going off. We can come back here and say add an event, and alarm is one of those events, and here's where we get to decide which alarm we're going to respond to, and I'll say alarm 0. So you should think for a moment based on the way the game works, pause the video, and think about what we should do here to say the cooldown period is over. Okay, hopefully you got this answer. I'm going to assign a variable, and I'm going to say can shoot, and I'm going to change it back to true. So the pattern we'll have here is over when we press the spacebar, if we can shoot, we'll create an instance of the French fries and we'll set can shoot to false, meaning we can't shoot anymore. And then we will start our alarm clock or our timer. When our timer ends, that means our cooldown period is over. We come here and we set can shoot to true, and that means we're cooled down and we can fire again. And if on the very next frame we're holding down the spacebar, then we do it again. We create French fries and so on. But if we hold down the spacebar while we're in the cooldown period, we won't generate any. This can shoot variable, which is called a Boolean. Booleans can be only true or false. This is also regularly called a flag. So Boolean variables that are set and cleared, made true and false, to control the behavior of our game are regularly called flags. Let's run it and see. And as you can see, now I have my automatic firing burger. So this is really nice. We have an automatic weapon. Our burger is an automatic weapon, and we can just hold down the spacebar to shoot. We should actually do one more thing as a nice gameplay touch. So what we'd like to do is, if the player chooses to spam the button instead of just holding it down, they should be able to shoot faster than they can if they just hold it down. So let's walk through how we can do that. The thing we want to do is we want to add a key up for the space. So this is the player releasing the key. And we will check if can shoot is currently false. So in other words, if we're currently in a cooldown period, we will then set can shoot to true. So in other words, if they release the spacebar while we're in a cooldown period, then we will come here, and because we're in a cooldown period, can shoot will be false. So we will set can shoot to true so that they can spam fire instead of auto fire. We'll take a look at that. So here's my automatic firing, and there's my spam firing. You see I can do it much faster, but I can go back to the automatic firing. The reason in my create event I set this cooldown frames is so that I can easily tune the game. If I want a faster firing weapon, I can make this 5 instead or something, and then when I run my game, even when I'm in automatic firing mode, I'm shooting much quicker. So having something that we're treating as a constant here to tune the game is really helpful. I'll just leave it at 30. And by the way, if the room speed is set to 30 frames per second, then 30 frames means 1 second. That's our cooldown. To recap, in this lecture we learned how to control our burger firing rate, we learned how to use a Boolean flag to control behavior, and we learned how to start and respond to alarms. Last time, we learned how to control the burger firing rate using visual events and actions. This time, we'll learn how to control the burger firing rate using code. So we won't go through the process of developing that whole solution one step at a time. I'll just add code here for doing the things we did over in the other project. We know in create, I added a can shoot variable that I set to true so that when the game starts, the player can shoot. And I also set a cooldown frames variable, and that was how many frames our cooldown period is. In my key down space, I actually now have an if statement So interestingly enough, let's do this two different ways so I can show you something. If can shoot, you might be inclined to say if can shoot is equal to true. Let me get rid of all the syntax errors and then we'll talk about this a little bit. And it is customary to indent inside curly braces. So those are two equal signs. This is called a relational operator. We're sort of determining the relationship between two values. So when we put a variable name on the left, it figures out the value of that variable, and then it compares it to true. And equal, equal, not just one equal, that's an assignment that we've used before. Two equals. If equal, equal, if they are in fact the same value, then this whole Boolean expression will evaluate to true and will come down here. And we did two things here. We set can shoot equal to false, and we started an alarm. And we don't know how to set an alarm in code, so let's go to the GameMaker manual. And I'll search on alarm. And if I scan these results, you'll see there's an alarm set function. And that looks like what we need. We use this to set an alarm. And we provide two arguments. We provide the index of the alarm. So this is like alarm 0 in the events that we can respond to in alarm 1 and so on. So we pick which alarm number or index we want to set. And we set the value to set the alarm to. And the value is the number of steps or number of frames that the alarm will run before it goes off. So we'll use the alarm set function with these two arguments in our code. So we use alarm set, and we were using alarm 0, and we're using cooldown frames as the value for how many frames that alarm should run. We also added the event where we responded to the alarm. And here, all we did was we set can shoot equal to true, right? That is not how I spelt it, and capitalization does matter. So that was how I spelt it, but I didn't capitalize it properly. But that's important in GameMaker language, so we want to make sure we get our capitalization the same. And the last thing I did was when the spacebar was up, if can shoot was false, I set can shoot equal to true. So here's two equals for the comparison, and here's one equal for the assignment. Let's run our game and then we'll come back to those Boolean expressions. Automatic firing, spam firing, just as before. So let's go back to the other place where we use can shoot. So we did that on space. So here, typing can shoot equal true is a lot like the drag and drop thing, right? We picked the variable, we picked the relational operator, we picked the value we were comparing to, and that made perfect sense. But I will say, because I know can shoot is always only going to be true or false, I can do this instead. So this is still a Boolean expression. It still evaluates to true or false. But because this is a Boolean variable, a variable that will only be true or false, I can just say if can shoot. And similarly, over here, and this might feel a little less intuitive to you, I can say if not can shoot. So the exclamation point is called a unary operator, and it negates whatever is here. So if can shoot is true, not can shoot is false. If can shoot is false, not can shoot is true. And I will say, before I show you that this actually works, I will say that it's much more common programming practice to do it this way than to say can shoot equal false, or can shoot equal true. So most code that you actually look at that has been built by good programmers will do it this way. I'll run it one more time. Automatic weapons, spam weapons. It still works great. To recap, in this lecture you learned how to control the burger firing rate using code. What will you learn in this lesson? You'll learn how to add background music to your game. You'll learn about the ideas behind the debugging process. You'll learn how to debug a visual game, and you'll learn how to debug a code game. In this lecture, you'll learn how to add background music to your game. Background music can make the game feel much more immersive for the player, so let's go see how to do that now. The first thing we should decide is which object should actually play the background music. We could use the object initializer, but that's in a different room, so we might as well start playing the music when we get to the gameplay room. We could pick teddy bear, fries, or explosion, but none of those make sense because there are multiple copies of them, so we'd have multiple copies playing the background music, and they're temporary. So once they're destroyed, they'd stop playing the background music. We can also consider using the burger, but it's not really burger behavior to play background music. It's really game level stuff, not instant stuff for that burger. So we're going to create a new object, and I'll call this object Game Manager because it manages the game, and we're also going to need to add another sound. So I'll come down to my sounds group and I'll right click and create another sound, and I'll call this sound background music, and I'll import the background music. And this time I'm importing an MP3, not a WAV file, but that's okay. MP3s are also supported by GameMaker, so I can certainly import an MP3 as a sound effect in my game as well. I need to do two more things. In my game manager, in the create event, I need to play the background music. So I'll come down to the music actions, and I'll play audio, and I'll pick the background music, and I will loop it because the player could play for a long time. If I ran the game now, we still sadly would not hear the background music because I haven't added this object to the room. So I'll add the game manager object to the room, and now I'll play the game and I won't talk so you can actually hear the background music. And there you go. That's how we add background music to our visual game. Let's go do the same thing in our code game. And I've already created the game manager object and I've imported the background music. So in the create event, we know we call the audio play sound function, and the name of the sound we're going to play is background music. We'll set it to priority 0, and this time we want to loop because the player could play our game for a long time. The other thing we need to do is add the object to our gameplay room. So I'll grab the object and drag it into the room. And again, I'll play the game without talking. And as you can see, we now have background music in our code game as well. To recap, in this lecture you learned how to add background music to your game, and you also learned how to use a game manager object to implement game level behavior that's not really appropriate for the gameplay instances that are in our game. Sad to say, sometimes your games will have bugs in them. And the only way to fix those bugs is to debug, get rid of the bugs. And so that's what we're going to talk about today. Before we actually go through the mechanics of doing that, let's talk a little bit about how debugging works. So here's how it works. We find an error in our code, a bug. Somehow it's not behaving the way it's supposed to behave. Before we go messing around in the debugger and sort of watching how our program executes and so on, we should form a hypothesis about what could cause this error. Because especially once we have lots of code, sort of mucking about executing one instruction at a time is going to take a long time. So you should form some idea about what might be going wrong before you go try to find it. So formulating a hypothesis. Now, I'll freely confess that sometimes as a programmer, I don't do that. I go sort of wander around in the debugger, but that's a stalling tactic. It's getting me working on formulating that hypothesis in the background while I do something else. I mean, I suppose I could go read a book or go for a run or something, but it's doing something while I'm trying to form a hypothesis. Once you form a hypothesis, you go and gather evidence, and we actually can't prove hypotheses to be correct, but let's not get technical about those kinds of hypotheses. Once you sort of figure out what you think is going wrong, then you use the debugger to try to discover if that is in fact the case. And then you sort of walk through the code and you look at values of variables and so on to see if your hypothesis was correct. And you might discover it was, and then you can fix the bug. Or you might discover it wasn't, but that's okay too, because you find a different place where the problem is actually occurring. Now that you know how the debugging process works, in this lecture we'll learn how to use the GameMaker debugger in a visual game. So let's say our burger isn't moving properly to the left. And we're not sure why, and we want to explore why. So we know it's probably going to be in the key down left event that we're having this problem. And we want to set a breakpoint. We want to run our game, but when it reaches a particular point, we want to stop and be able to look at values of the variables that are in the game right at that point. That's generally the idea behind setting a breakpoint. As you can tell, I'm in our drag and drop version of the project. So I will right click this action and I will say toggle breakpoint. You can also use F9 for this, but I have now set a breakpoint at this if statement right here. And you can also see that there is a red box around that breakpoint to show that there is a breakpoint set there. Now I run my game, and I don't run my game using this run button, which is F5 the shortcut. I run my game using this bug button, or the debug button, which is F6. So if I want to debug, if I want to stop when I reach this breakpoint, I need to run the game in debug mode, not just in regular mode. So I will start running the game, and it takes a little bit longer to start up. And now when I press left, you'll notice that my game stopped. You'll also notice that I ended up here in GameMaker language. We've already talked about the fact that GameMaker Studio converts our drag and drop actions into GML before we run the game. And certainly at the debugging level, we need to be able to be looking at code. So we can set a breakpoint on an action, but when we actually break at that action, we end up in our GML code. At this point, we can look at the values of the variables that are in our game. So I've zoomed in again. We end up with lots of tabs along the bottom here, and you'll notice that one of them is the Instances tab, and the Instances tab lets us pick the instance we want to look at. Because we set our breakpoint in the object burger, over here on the left is our object burger. So the current instance we're looking at is over here on the left, but we can pick other instances too. Like any of the teddy bears that are currently in the game manager is actually placed in the room and so on. We can also click the Variables tab to look at variables inside this particular instance. And this is self, and I expand this, and that gives us exactly what we had in instances. So at this point, we can start looking at things. We can look at all these custom variables that we added to the burger object. So we've got cooldown frames and move amount and half sprite width and half sprite height and can shoot. And we can also look at built-in variables. And at this point, my burger is at 672 in X and 672 in Y. Up above, I am right here in the game, and I can also hover over variable names up here to look at their values. Now, we have some control things along the top. We can step into a particular function call. So if we're calling a function, which we're not doing here, we're just evaluating a Boolean expression. But if we're calling a function, we can go into that function with the debugger and step through that one as well. We're not doing that here. We can step over a function call, which means we don't actually go into the function and with the debugger, we go run the function and come back and move on to the next line in our GML. And we'll actually use F10 to step over this particular line of GML code as well and move on to the next one. And if we continue, we'll move forward to the next breakpoint, or if we don't hit another breakpoint, we'll be back in the game again. Let's evaluate this Boolean expression ourselves. So 672 minus 16 is 656, minus 5 is 651, and that's greater than 0, so we expect to end up inside the body of this if. If we have 10, we see that that's exactly what happens. So the line of code we're on right now is highlighted with red, and it's not a breakpoint. We don't have a red circle over here, which indicates we have a breakpoint, but it is the current line of code we're about to execute. We haven't executed it yet, but we're about to. So remember, X is 672 right now, and I'm going to add negative move amount to X. So I'm at 672, so I would expect that the next time I get here, I will actually be 667. I can continue running the game, as I said, by clicking this or pressing F5. So it continues and there's no more breakpoints. I will give focus to the GameMaker game again and press left again. So I'm back here in the debugger again. And if I scroll down, you'll see that I actually do have X of 667. So there isn't actually a bug in this game, but this is the process that you use to use the debugger. An important point is that I had to click on the window that was running the game to make it listen to my input again. It's easy to forget that, and you come back to the game and you start pressing stuff and nothing's responding. You actually have to give the game focus in Windows to actually make it respond to input again. Remember, I can also look at other objects like this first teddy bear. In this first teddy bear, right now, its X is 590 and its Y is 190. If I press F5 to continue, give the game focus, move the burger again, so I come back here, you can see that that teddy bear has moved a lot in X and moved a lot in Y. So we're not limited to just looking at the variables in the object in which we placed the breakpoint. We can look at the values of variables in other instances of the game as well. Okay, I'm going to stop debugging, and I'm going to stop magnifying. And this debugger window appeared when I started debugging. You can just get rid of it like that, and now it's gone. So that gets rid of the debugging stuff that you had before. That's kind of irritating to have it sticking around after you've done stuff. That is sort of using the debugger the way it's designed to be used. I will show another way to print out values of variables that you might be wondering about. So first of all, I'm going to toggle this breakpoint so it's not a breakpoint anymore. But if you come over here into the action toolbox and scroll way down to the bottom, you can also show a debug message in the output console. So if I want to print out the value of X when I'm responding to the left key down event, I can just drag this action over, say what value I want to print. So now I can run my game again using the bug icon or F6. And if, once my game starts running, I move it up a little bit so I can grab that output pane. If I give focus again over here, if I move left, you can see I've moved as I press the left key. And it's printing out the value of my X every single time. And you'll notice, if I get over here, I stay at 16, which is half my sprite width, because I've been clamped in the screen. And again, I was running the debugger so I can get rid of that. But that is another way to sort of easily print out values of variables that you know you want to look at as you run the game without stepping through the GML code to do it. To recap, in this lecture you learned how to use the GameMaker debugger in a visual game. Last time, we looked at how to use the GameMaker debugger in a visual game. This time, we'll look at how to use the GameMaker debugger in a code game. Okay, we're in our GameMaker language project, and I've selected the left key down event that we're responding to. Here's our GML code, and really all the ideas are the same as for when we did a drag and drop game. The only real difference is how do we actually set a breakpoint. And we can do that by here on line 1. If we go to the left of the line number and left click the mouse, I've set a breakpoint there. And if I start my game in debug mode and I press the left key, I stop at the breakpoint. As you can see, I can look at all the different instances in the game. I can look at my built-in variables. You can see I didn't place it exactly in the same place in the room in my GameMaker language project. But I can step over using F10. I can press F5 again to continue. If I give this window focus and press left again, I come back to the breakpoint. So everything works exactly the same way it did in the drag and drop game. I'll just stop debugging. Except that I place breakpoints by left clicking in this area over here, and I remove breakpoints by left clicking on the breakpoint. So that is toggling the breakpoint like we did in our drag and drop game. To recap, in this lecture you learned how to use the GameMaker debugger in a code game. What will you learn in this lesson? You'll learn how to do something every step or every frame in your game. You'll learn how to add health to a visual game, and you'll learn how to add health to a code game. Well, it's finally time for the teddy bears to start fighting back. So in this lecture, we'll learn how to make the teddy bears move toward the burger. Unfortunately, they won't actually damage the burger until the next lecture. We're going to implement this behavior in our teddy bear object, and what we're going to do is on every frame of the game or every step, we're going to make the teddy bear move towards the burger. So I'm going to respond to a new event, and you'll see here in step, we actually have 3 possible step events to respond to. We can respond to step, which is the middle of the step. We can respond to begin step, or we can respond to end step. So if you're doing something more complicated than what we're doing, you may care that something happens at the beginning of the step versus the end of the step or in the middle. But for us, we can just pick the middle of the step as the event that we're going to respond to. So what do we need to do? We need to point our teddy bear at the burger to make it move toward the burger. So let's go down to the movement actions. And as you can see, there's a set point direction action. So we'll drag that one over. And we need to put the X and the Y as a point that we want to point toward from our current location. Because there's only one burger in the game, we can say object burger dot X, because we can access the instance variable for the object burger even from outside the burger object, and object burger Y as well. So now every step, every frame of the game, we're going to set direction to point from our current location toward objectBurger.x and objectBurger.y. Let's run the game and see what happens. And as you can see, they all point toward me, and now they're sticking with me too. I can run away from them if I go diagonally because of that Doom Strafe 40 bug, but they still come get me. Now, one of the things you may not have noticed is that the teddy bears aren't actually pointing toward the burger, although they are moving toward the burger, so the direction built-in variable is getting changed, but the sprite keeps pointing toward the original direction they were moving in. And we would like to fix that. So this is in instances. And if we look at all the icons and even hover over it and read stuff, we can see that we can set the instance rotation, and the angle that we want to point is direction. And notice, we already did that here in the create event. Remember, we made our teddy bears point in the direction that they were going in when we created the teddy bear. But here, we're changing that direction every step, so we need to change the rotation every step as well. Now, I'll move the burger around a little bit as I run the game, so you can see them pointing different directions, but they'll always point toward the burger now. And isn't that great? They're all chasing me, and they will eventually catch me. But it doesn't even matter because they're not inflicting damage on me. That will happen in the next lecture. Let's go over and see how to do the same thing in our code game. Again, we'll respond to the step event. And what we don't know is how do we actually point toward the burger. We could go looking in the manual to try to figure this out, but we can also do the live preview here and see that it is in fact point direction. So now let's go to the manual and we'll search on point direction. And you can see that this returns the direction of a vector that goes from us to a target point. So when we call this function, we'll call it with our x and our y, and then the burger's x and the burger's y. So we'll call point direction, and we'll pass in our x and our y, and the object burger's x and the object burger's y. And I need to capitalize the B in burger there. So let's make sure this part works. And of course it doesn't, because this returns a vector and we need to set direction equal to that vector that it returns. Let's try that again. And as you can see, the teddy bears are following me, but they're not pointing at me. We know how to fix that as well, because we can say image angle equal direction. Running the game one more time. And now it works just like our visual game worked. To recap, in this lecture we learned how to make objects move toward a specific point, and we also learned how to use the step event to make something happen on every frame. Now it's time for the teddy bears to really fight back by inflicting damage on our burger. We'll see how to do that in our visual game in this lecture. All our work is going to be here in the burger object. We'll start with the create event, where as you can see we assigned a number of variables, but we're going to assign a couple more. So the first thing we want to do is to set the health of the burger as 100. We'll start at 100, and I haven't shown you this before, but in this search box I can type health and it will give me all the results for health related actions, and we can draw health, which we'll get to some other time, but I can set the health, I can get the health, and I can say if health for the instance's health. So we're going to use set health for the burger, and we'll start it at 100. And the other thing that I actually need is I need to assign a variable for how much damage a teddy bear does when it collides with the burger. So I'll assign a variable here, and I'll call it teddy bear damage, and I'll make that 40. So a teddy bear does 40 damage to the burger when it collides with the burger. That means that I should respond to a teddy bear colliding with me here in the burger object. So I'll add an event, and it's a collision event with objects, and it's the teddy bear that I want to respond to colliding with. When I collide with the teddy bear, I want to find those health actions again, and I want to set health to negative teddy bear damage relative to my current health. So that will reduce my health. I can run the game now, and it's reducing my health, but we don't even realize that that's happening. So our next step is to check the health to see if the burger just died. So we'll drag over the if health, and we're going to say less than or equal to 0. We don't want to check exactly 0, because what will happen is the first collision with a teddy bear will reduce health to 60, the second collision with a teddy bear will reduce health to 20, and the third collision with a teddy bear will reduce health to negative 20, which isn't 0, but clearly the burger is dead. So what should we do if health is less than or equal to 0? Let's just restart the room. So I searched on room, and we'll restart the room if that happens. Now watch carefully to see what happens here when I run the game. Boy, I'm dying really quickly even though one teddy bear is hitting me. So here's the problem. When I collide with a teddy bear, or when I'm in collision with a teddy bear, I reduce health. But then on the very next frame, I'm still colliding with that same teddy bear. He's sort of tunneling his way through me or something. And so I'm getting a health reduction from that single teddy bear all the way to kill me. What we need to do is when a teddy bear collides with me, that teddy bear has done its job and I should destroy it. But we don't want to just pick destroy instance, because that will destroy the burger object. We want to click this little drop down arrow and say we want to destroy the other participant in the collision. And once we've selected that, you can see it says to the right, destroy other. So this will be the other participant in the collision, not me. So if I run the game now, the first teddy bear that collides with me takes away health but is destroyed. And then I restarted the room, and you can see that happens after the third hit. One other thing that would be really helpful to the player here would be to show visually about what level of health they have. And to do that, I'll show you that I imported 2 more sprites. I have a burger sprite that's 1/3 health, and a burger sprite that's 2/3 health, and the full health burger. So I will display the appropriate sprite based on the current health of the burger. So I'll drag this if health down here. And what I'll check is if the health is less than or equal to 33, I'm going to set the sprite for the burger, and I'll set it to the 1/3 health. Then I'll add an else for this if statement, and then I'll add another if. So if the health is less than or equal to 66, then I will set the sprite to be the 2/3 health burger. And then finally, one more else. I will set the sprite to just be the burger sprite. Putting one if statement inside another if statement or an else for that if statement is called nesting if statements. You can visualize why it's called that. I'm going to leave it up to you as a mental exercise to figure out why we need to go small health up to large health rather than large health up to small health, at least using less than or equal to. We could do it a different way to go full health down to lower health, but I chose to do it this way instead. So now, when we run our game, after the first hit, you can see I have a bite out of me, then 2 hits, I have 2 bites out of me, and then we'll restart the room, and of course I got bitten right away, and so on. There's one more thing that I'd like to add to make this even more enjoyable when I'm taking damage. I added another sound effect called sound health reduction, and when I take damage, I want to play that sound. So I'll scroll down to playing sounds, and I will play the health reduction sound when I get hit. And this time I won't talk while I play the game so you can hear that sound effect. Ow! 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 And that's how we can add health to our visual game. To recap, in this lecture we learned how to use instance health to inflict damage, how to display the appropriate sprite for an instance based on its health, and how to take some action when the player dies. Last time, we learned how to add health to our game using visual events and actions. This time, we'll learn how to do the same thing using code. Recall that the first thing we did in our visual game was we went to the create event for the burger object and we added a couple more variables. We added an instance health variable and we added the teddy bear damage variable. I can put the teddy bear damage variable in right now. But for instance health, we don't really know if that's a built-in variable or if it's just something we should name for ourselves. You might guess that it's health, but that actually turns out not to be true. There is a health variable that is for the entire game, not for this particular instance. The easiest way to figure this out is to go back to our visual game, and I'll show the live preview here, and we can see that instance health is actually called __ DND, which stands for drag and drop, _ health. We can just use this name, or we can come up with our own name. Let's use this name. So it was __ DND _ health, and we set that equal to 100. The next thing we did was we started responding to a collision with the teddy bear. And in that collision, we took our instance health and we subtracted teddy bear damage from it. And I'll run the game just to show that this doesn't crash or anything. So we're reducing the health. We also discovered that we should destroy the other participant in the collision. So we know how to do an instance destroy for other. And now what should happen is, as each teddy bear runs into the burger, that teddy bear should be destroyed. and we can see it is. And now I'm going to determine whether or not the burger has run out of health. We're starting to write a lot of code here, so I'm going to start adding some comments. Reduce health and destroy teddy bear. Check for no more health. And it's an if statement. And we'll check if D&D health, and I lost my parenthesis when I selected that, so let me get it back. If D&D health is less than or equal to 0, then we're going to do something. And we're going to restart the room. And we can just start typing and hope that the pop-up helps us. And of course it does, because there's a room restart function that we can just call. So now if I run my game, when I get 3 hits from teddy bears, we'll end up restarting the room. I tried to run away, but I couldn't. So that part is working. The next thing we did was we set the sprite based on the burger's health. So if D&D health is less than or equal to 33, then we set the sprite to be sprite burger 1/3 health. We don't know how to set the sprite, but we can type sprite because we're messing around with the sprite. And you should have realized by now that lots of times something called sprite index or object index is actually the name of that sprite or object. So I can just set sprite index equal to sprite burger 1/3 health. Next, we had an else. And when we explore the selection control structure more in the last course in the specialization, we'll learn about something called else if. But for now, let's just make it look like the visual game looked. And we'll say an if statement inside this else. And we'll check to see if D&D health is less than or equal to 66. And if it is, we'll set sprite index equal to sprite burger 2/3 health. And then finally, we added an else here. And in that else, we set sprite index equal to the sprite for the full health burger. Let's make sure that piece works. I have 1 bite out of me. I have 2 bites out. That happened very quickly. I got 2 bites out of me. And then when they get me, I restart the room. So the only other thing we have to do is to play a sound. So let's do that up here. And we know how to play sounds. We use audio play sound. And the sound we want to play is the health reduction sound, and we'll make it top priority, and we won't loop it. So again, I'll play the game this time without talking, so you get to hear that sound effect as well. Ow! 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 And there you go. We've implemented health in our code game. To recap, in this lecture you learned how to add health to your game using code. Great job making it to the end of the course. I hope you had a lot of fun, and I hope you learned a lot as you continued to develop your GameMaker skills. As a reminder, in this course, you learned how to implement player movement, you learned how to add shooting to your game, you learned how to use the GameMaker debugger in both visual games and in code games, and you learned how to add health to your games. There's still lots to learn about developing games using GameMaker, so if you'd like to continue learning in a structured environment, you should move on to the next course in the specialization. I hope to see you there. No matter what, I want to thank you for taking this course from me. I love doing these courses on Coursera, and I'm glad you decided to join me as you continue developing your GameMaker game development skills. Cheers.